Remember this game? RuneScape, my literal childhood. I spent the last few weeks making a ChatGPT plugin, but augmented with data from this game's wiki. The results were interesting. So why did I build this? I've been looking for the perfect intro project to get into the world of large language model AI development. Smart choices probably would have been like a chat with your PDF app, or chat with a YouTube video, chat with a podcast. Those probably would have even made me some money, but fuck that. I wanted to do RuneScape. And RuneScape actually has hella data to work with. There are 27,000 articles on the wiki, not to mention a ton of YouTube videos, a subreddit, or even WikiHow articles like this one on how to get 99 in all skills. And because there's so much data, I figured this would make the perfect first project. With our goal in mind, here's what we needed to do. Step 1, scrape all the data. Step 2, process the data in whatever way we need to do the actual AI stuff. Step 3, store all that processed data in some database. Step 4, make a RuneLite plugin that lets users actually type in commands or type in questions. And for those who don't know, RuneLite is the open source game client that a majority of players actually use to play the game. And it has this neat third-party plugin ecosystem which lets developers like myself make plugins and lets players download them and be able to use them. Step 5 is to be able to query my database for the relevant documents given the user's question. Step 6 is to use some AI APIs to actually summarize that information in a natural human language way. Step 7 is profit. Just kidding. In fact, I will probably lose a considerable amount of money from this project. Okay, let's go over the system architecture. So the life of a query, if you will, would be something like the following. First, the user is going to actually download Scape GPT into their RuneLite. Then they're going to type in a query or some sort of command and submit it. That'll get sent to a private server that I'm maintaining. On my server, I take their human language query and convert it into something called an embedding, which is basically a machine representation of the semantics of that text. We'll talk more about embeddings later in the video. So I then query my database, which is hosted on a different server, and my database is going to have tens of thousands of these embeddings, which is the actual content I'm storing, like the wiki docs or the YouTube video transcripts and so on. I'll ask my database to give me the 3 most relevant pieces of context given the user's query, and then make an API request to OpenAI's chat API, basically giving it the text content of those 3 documents that my database returned alongside the user's query, and ask it to summarize or otherwise give a good answer to the user's query given the context of those 3 documents. Then I'm going to take that answer that it returns to me and forward that all the way through to the user's RuneLite client. To start, I set out to get all the data I actually needed. I decided to first hit the wiki, and spoiler alert, this ended up being the only data source I actually used because I got a little bit too lazy to scrape YouTube and of course WikiHow. But if I make a part 2 to this video, then we'll do some of the other data sources. So like I mentioned earlier, the wiki has so many articles, over 27,000 of them. We can't summarize those by hand. We're going to have to write some sort of scraper and auto summarizer. But first, how do we even get all 27,000 of those articles? Well, my first theory was that every single article is probably connected to at least one other article, so they make this giant web of articles. And if I just did some sort of graph search starting from one article, I could eventually find every other article that way. But then I found this page and it just had all the categories, and within each category you could click around and find the subcategories, eventually finding all the pages under a specific subcategory. And so it ended up just being as simple as creating a crawler to go across the categories. I still feel like the graph thing would have been way cooler, but you know, this was just more simple. Then I realized each article has so much different types of content that you have to account for. Consider this Zalra article here. You have the info box with all this information. This different article here, you have a completely different type of info box of stuff you need to account for. And that's just the right-hand side. Then there are these skill boxes. There are all these tables. And let me just tell you, those tables were the absolute worst part. So there are 2 parts to get all the data we need. I'm gonna write a crawler that goes across all of these categories and gets the URL slugs for each individual article on the wiki. Then I'm gonna write a scraper that actually visits each slug one by one, gets the HTML content from it, and parses it into a simple text file. I decided to work in Python because Python is goated. Initially, I tried to get ChatGPT to do as much of the heavy lifting as possible, but I only have so much context size to work with, and eventually it just stopped being useful after a little while. Granted, I did use ChatGPT for the smaller things, like how do I read in a file, write me a quick little parser in Beautiful Soup to do XYZ, so it's useful for that. But for a majority of it, I did have to do it myself. Okay, so it took a few hours, but I eventually hacked together this giant spaghetti mess of Beautiful Soup code, and I got this basic scraper working, which was just set to scrape articles across the scenery category. I figured that would be kind of a simple, good first category to test. As you can see in the output in the terminal here, I was printing unfamiliar headlines within the articles so that I could go back and manually check to see if there are any new types of content representations that I would need to manually account for in the code. This ended up just not being scalable because there are so many unique headlines across all 27,000 plus articles that I eventually just hoped I had accounted for most of them within the code, and any that I did account for, oh well. And after many hours of refactoring, we had a crawler that would appropriately crawl across all the categories, get all the URL slugs, and then our main scraper script with some utility functions to actually handle all the edge cases. Please don't look at the code. It is actually atrocious, but hey, at least it works. Or does it? I mean, for some of those crazy tables like I mentioned earlier, it just does not work well. Like, look at this one. It's pretty simple, but now look at this one. It's got nested columns, and it made me realize that there's no way to generalize this scraper across all types of tables that actually could exist in the wiki. And I could have kept trying to customize it further, but I got pretty lazy at this point and made the executive business decision to just stop right around there. Hopefully the pages that we failed to parse are ones that no one's going to ask about anyway. There's no point in storing just the text of these wiki summaries in our database. We actually need to get embeddings of them. So what's an embedding? Let's talk about an example first. Let's say I give you the sentence, the lizard attacked the grasshopper, and then gave you another sentence, the reptile ate the insect. As a human, you know that these sentences are semantically similar, but it's not as simple for a machine to know that. Let's say I also then give you the sentence, hi, I'm a robot. If we were to plot these three sentences in a 3D graph of similarity, the first two would probably be pretty close together, and the third would be somewhere far off. So what these super smart ML researchers did is figured out how to encode the semantic meaning of some text in a high dimensional vector, which is basically a fancy way of saying a giant list of floating point numbers. Each number in the vector represents a new dimension. So going back to our previous example, maybe for each of these sentences, they are turned into vectors or arrays of size 3. So 3 floating point numbers in them. The advantage of using these vectors for text is that you can actually take the similarity then between two vectors using relatively simple math. Specifically, there's something called the cosine similarity, but there's a couple of other ways to get the similarity between two vectors. Those algorithms return a number between -1 and 1, where -1 is completely not similar and 1 is the exact same sentence. So with our previous example, the first two sentences might have a higher cosine similarity, and the third sentence between the first two would maybe be negative. Now, of course, 3 dimensions isn't that many, so the actual API that we're going to use, the OpenAI embedding API, outputs vectors of size 1536, which we can't conceptually visualize, but they make this embedding search pretty good. So the TLDR is we can use this embedding API to actually turn all of our summaries into embeddings. Then we actually have to store those embeddings somewhere. Vector databases are the industry standard way of storing embedding. They're like regular databases, except of course optimized for indexing on vectors, which just makes it a lot more efficient to search across the entire database very quickly. Initially, I started working with this one called Chroma. Chroma was really nice. It worked really well out of the box with Python, but unfortunately they didn't have a hosted product offering. So while it was really good for development in the beginning, while I was playing around with the embeddings and getting familiar with them, I knew that I was probably going to be too lazy to figure out how to host Chroma myself on my own server. And so I knew I would probably need to switch to a service that would do all the hosting for me. After a little bit of research, I saw that Postgres has this PG vector extension that recently came out, which basically enables indexing on vectors easily within Postgres. So that's perfect. I can just use an existing Postgres instance with this PG vector extension hosted on a familiar product like Supabase. And with that, I could probably probably even still get away with being on the free tier. But I ran into an issue. Unfortunately, all vector databases are not made equal, and I learned this the hard way. They use different algorithms, different search algorithms to actually find relevant documents. The one that PG Vector uses apparently just isn't good for the way that I was summarizing the OSRS wiki articles. Like, look at this example. I would type in a question like, who is the big high war god? And obviously if you play the game, you know that that's Bandos, but it wouldn't even return me the Bandos wiki article, whereas Chroma would. So for some reason, the search algorithm that Chroma uses under the hood is superior for the way that I'm representing my text compared to PG Vector. And so I knew I would actually need to use Chroma, so I resigned myself then to actually figuring out how to host Chroma. And surprisingly, it was really easy. The documentation was crisp. I got an EC2 instance running within 10 minutes flat with the hosted Chroma on it, configured with the exact amount of compute and memory that this long-running instance of Chroma would actually need, and I was all set. So at this point, I was feeling a little bit of AI fatigue, and I kind of wanted to work on the RuneLite portion of things, which I figured would be pretty interesting since A, I haven't actually worked on a RuneLite plugin before, B, I also have not worked in Java for months, and I weirdly thought that that might be refreshing. So I was going through the source code for some of the other plugins like the Grand Exchange plugin or the Notes plugin, and those both served as really good references, but I still ended up just asking ChatGPT to write everything for me because I was too lazy to read the Java Swing documentation, which is actually how RuneLite plugin UIs are made, and that worked really well. It literally wrote the entire plugin for me. So before long, I got a pretty simple UI spun up, and then I made this janky placeholder logo for Scape GPT in Photoshop and got that janky logo to show up in the sidebar on my development version of RuneLite. I then spun up a local version of Flask to make sure it was possible to even do HTTP requests from within RuneLite, and it was. Now at this point, we needed to set up our actual server. Why do we even need one? In theory, I imagine it's possible to just hit Chroma directly from RuneLite, but I don't think Chroma has a Java client library, and also the OpenAI APIs, they seem to only be usable within Python and JavaScript. I figured I also just need rate limiting too. Rate limiting is just for the off chance that people actually use Scape GPT, in which case I don't want my OpenAI API usage bill to skyrocket. And so I figured I would set a rate limit of like 20 questions a day and maybe a couple per minute. So I followed a guide on how to set up a simple Flask server using GUnicorn on AWS EC2, and that worked pretty well. And then I used this built-in library for Flask to actually do the rate limiting, which worked like a charm. And yeah, it was probably the most simple server setup I've ever had to do in my entire life. There is literally a single endpoint / query, and it's not more than 30 lines of code. Things were looking pretty good at this point, but I started running into this issue related to these things called tokens. This is going to require some context, so bear with me. OpenAI uses the concept of these things called tokens, which is basically their way of representing a piece of information. Don't think about it like a word or a character, but very roughly, maybe 100 tokens is equal to 75 words in English. Unfortunately, you can only pass 4,000 tokens to OpenAI's chat API, but keep in mind that I'm passing in the full summary of the wiki articles for 3 different articles, as well as the user's prompt into one of these API calls. And sometimes that would total more than 4,000 tokens, which is bad. I actually don't know what happens. I imagine they just truncate everything past 4K tokens, but this leads to a problem because we want to have all the context available when actually making the answer that we're going to return back to the user. So I found this open source library called Llama Index, and Llama Index lets you get around the 4,000 token limit basically by making multiple calls to the chat API if all of your context is greater than 4,000 tokens, and then gathering all the responses from those calls and summarizing them, so that ultimately you end up with a single summary that was gathered using all the context that you initially provided. Llama Index is actually insane. Like, there's all these different ways that you can do this. I ended up settling on this tree index. If you ask me why, I wouldn't be able to tell you, but it ended up just giving me the best results. And yeah, as you can see here, we got things working. We need to finish the plugin now. I set the plugin to hit the IP address of my server. I tested it out at this point and things were looking pretty good. I did run into an issue here though, which I could not figure out for the life of me. Any call to the server was capping out at 10 seconds maximum, including the response time from the server, and ChatGPT wasn't giving me the answer here. So I ended up just asking in the RuneLite Discord, and Cyborger1 saved my life by giving me the exact code I needed to use, and that worked. So I set the timeout to 45 seconds for both the call and the response, which I feel like should be enough time for any query that any user submits. Next, unfortunately, the placeholder logo needed to go. I tried to get creative here and use Midjourney to generate a logo for Scape GPT, but all the ones it gave me were kind of garbage. And then I realized I actually just need a super simple RuneScape-y looking chat bubble. So I yoinked one from some screenshot I found on Google Images and did a little bit of Photoshop magic, and then we got this. Lastly, with everything in place, I submitted the PR to actually merge Scape GPT into RuneLite's official plugin hub so it would be available to people. Sweet, that about wraps it up. Not sure yet if I'll make a part 2. There are definitely some improvements to be made, so TBD on that. If you made it this far, thank you for watching. Please like and subscribe for more.